All right, my name is Mete Atamel. I'm a developer advocate at Google. I'm based in London, and it's first time here in Sydney and Australia, so I'm very excited to be here. So today we're going to talk about building ASP.NET apps on Google Cloud. I usually post my slides after my talk, so if you just follow me on Twitter, I will have my slides up there. And if you have any questions about any of the stuff I say today, we have a Google Cloud booth here at NDC. Feel free to stop by. I'm going to be there today and tomorrow and Friday. But you can also send me an email anytime after this week. I'll be happy to answer your question. And I also have a feedback link, but I think they also have feedback things that as you exit. So as you exit, please let me know how I did, good or bad. I always like the feedback, so feel free to do that. All right, so what we're going to talk about is first I want to do a little bit of introduction. So the first 10 minutes or so, we're going to answer the question of why Windows, why ASP.NET on Google Cloud. Because I get the question a lot from people. So I just want to go through that quickly and look at like why should you even consider Google Cloud when it comes to .NET development. So that's one. After that, we're going to look at a simple ASP.NET application running on Windows. I'll show it on my laptop. And then we'll push that application to Google Cloud, and we'll take a look at the process of how that works, and what kind of process you have to go through to push your application to Google Cloud. Moving your app to the cloud in itself is not that interesting, because instead of running it on your data center, you're running it in someone else's data center. But I think the power of cloud is that once your app is in the cloud, you have access to all these different services and tools and machine learning. So in the next part of the talk, I'll talk about some of the services in Google Cloud, such as cloud storage, vision API, and speech API. These are the machine learning APIs. And what we'll basically try to enhance our app using these services. And I'm also going to show some PowerShell commandlets and see how we can script things. And then in the last part of the talk, I want to talk about the containerized world, because everything is becoming containers. And then with ASP.NET, we have ASP.NET Core that runs on Linux. And you can take that and you can containerize it. And then after that, you can deploy it to App Engine Flex on Google Cloud. And you can also deploy it to Kubernetes running on Container Engine. So I just want to talk about those and let you know which one makes sense more and stuff like that. So we should have some time at the end of the talk for questions. But if you have a burning question that you want to ask right away, feel free to stop me as well. All right, before I start the introduction, I'm also curious, who is running services in the cloud today? Okay, a lot of people. And who's running on Google Cloud? Yeah, a couple of people, that's good. All right, and I guess most other people are running on Azure, is that correct? Okay, Azure AWS, okay. I always ask these questions because I want to know like what the ratio is and things like that. All right, so the intro is, I guess the first question that you have is, Windows Server, SQL Server, ASP.NET Framework on Google Cloud. Like, when people hear this, they're like, oh, what's happening, Because when you think of Google, you think of search, you think of machine learning, and we invented the language Go, and then most of our services are written at Google on Go or Python or Java. So when you think of C# and .NET, you don't really think about Google at first. But this is changing. In the last couple of years, we've made a lot of investments in Google Cloud, and we are trying to make C# one of what we call silver languages. So it's one of the main languages that we want to support on .NET, and this is what this talk is all about. But if you look at the world that we used to live in 2014, it kind of looked like this. So on one hand, we had the open source world with the tools and languages around them. And then on the other hand, we had the .NET world with tools and languages around them. And we could argue back and forth about which one is better. Is Java better than C#? I started as a Java developer, for example, then I switched to C#, and I personally think that it's much better than Java. But then the unfortunate thing is that these two worlds, they didn't really interact with each other. So I started my career on this side, on Windows side, doing Java work. At some point, I moved to Linux, and I did Java. Then at some point, I started working for Microsoft, so I switched to C# and .NET. And doing this back and forth switch between these two worlds was always painful, because even though they were trying to do similar things in these two worlds, they were different enough that it made the transition kind of painful. But if you look at what's been happening in the last couple of years, it's kind of amazing. First, .NET went open source, which was big news. And then gradually, we started seeing tools and languages moving from Linux to Windows and Windows to Linux. So we had OpenSSH move from Linux to Windows. Then we had Ubuntu and Debian Linux operating systems running on Azure. We had SQL Server and PowerShell moving from Windows to Linux. Then we had Bash coming from Linux to Windows. And for me, the biggest thing was ASP.NET Core. So the community at Microsoft created a lightweight version of ASP.NET that runs on Linux, Mac, and Windows. And this opened up a lot of opportunities. And you'll see what this means for Google Cloud as well. You know, as I mentioned, I used to work on Java. And then when I switched to C#, I liked everything about it. But I was really bothered by the fact that I can only run it on Windows. And with ASP.NET, with .NET Core, now .NET runs everywhere. And I don't have that question in my mind anymore, which is great. And the year 2016 ended with two announcements. First, Microsoft joined to Linux Foundation because of their work. And then Google joined to .NET Foundation because of our work in Google Cloud Platform. So I think we had like a couple of interesting years when it comes to .NET and C#. So if you look at what we have today, we still have the two operating systems, but all the tools and languages around them, they're kind of converging. And that's why we have things like .NET and C# running on Google Cloud, and that's why we have things like PowerShell and SQL Server running on Linux. So what this means for you is that I think it's a great time to be a .NET developer. I'm glad that I did this switch, and I think .NET is getting better and better, so I think we're lucky. So that's my pitch for .NET. But now let's talk about why should you even care about Google Cloud when it comes to .NET and Windows. And let's look at this question from a consumer perspective. Let's say you're a cloud, you want to buy cloud services, and why should you care about Google Cloud? For me, it kind of boils down to three separate buckets. The first one is the infrastructure. So when you are running in Google Cloud, you are running in Google's own private network. So even if you have two services on two data centers, and when they need to communicate, they will communicate on the fiber optics that Google owns. So it doesn't really go through the internet. It goes through Google's own private network. So what this means is that things are really fast. Latency is really good. Throughput is really stable. So it just works much nicer. And because of that, we have VMs that provision really fast. So if you want to get a Linux VM, you can get that within like 10, 20 seconds. And if you want to get a Windows VM, it's a little bit faster, a little bit slower than Linux, but it's still quite fast. Within seconds, within 30 seconds, you can get a VM. And because VM provisioning works really fast, autoscale also works really fast. So if you have lots of load coming in, you can autoscale within seconds instead of minutes. So that makes a difference when you need to scale up. So that's the infrastructure. The second thing is pricing. So the pricing of the services themselves, they're really competitive compared to other cloud providers. But not only that, we also build features to make pricing even better. For example, in VMs, we have per minute billing. So when you use a VM for 10 minutes, you get charged 10 minutes. You don't get charged for the whole hour. If you use a VM for the whole month, you get 30% discount by default. You don't have to do anything special. And this is my favorite. We have sizing recommendations. So let's say you have a big VM with lots of CPUs and memory. We kind of detect your usage of the VM. And if you're not really using it, the Google Cloud will tell you, by the way, this VM is not being utilized. You can actually downscale that to a smaller VM so that you can save money. So we try to build all these features to make it even cheaper for you. And the last thing is the flexibility with the machines. So we have VMs in many shapes and sizes. They are custom built. They're built like they're micro instances, standard instances, big instances. But you can also have custom built VMs. So you can say, I want this many CPUs and this much memory. And only pay for what you want. So you don't have to get a big CPU and big memory just because you need big CPU. You can basically customize whatever you want and pay for what you're using. And the last thing is the printable VMs. So we have these VMs that are kind of given to you, but they can be taken away from you at any time, depending on the load in Google Cloud. But the good thing about them is that they are 80% cheaper than normal VMs. So in some use cases, for example, let's say you have like a queue of work, and you can do that with 10 VMs, or you can do that with 20 VMs. You don't really care. You can use printable VMs, and that way it will be much cheaper for you to process the queue of work. But at the same time, these VMs can be taken away from you at any time. So this is why Google Cloud in terms of as a consumer, but in terms of why Google Cloud as a developer, it also boils down to three separate buckets for me. The first one is the deployment options. So if you want to do virtual machines, we have something called Compute Engine that I'm going to show in my demos. If you want to do containers, we have Kubernetes, managed Kubernetes on Google Cloud, and you get that with Container Engine. If you don't want to care about VMs or containers, but you just want to deploy your code and let Google scale that and run that for you, we have App Engine. And then if you don't even want to care about applications and you just want to deploy functions, we have Cloud Functions. So depending on what kind of management you want to have, we have different options. So once you have your app running in the cloud, we have a number of services that becomes available to you, such as Bigtable, storage, Cloud SQL, BigQuery. And there are actually some talks on some of these. Like there's a talk on BigQuery that's happening right now. There's another one tomorrow if you want to learn more about it. But the key thing about these services is that they're really managed. For example, BigQuery is a data warehousing solution where you ingest lots of data to BigQuery, and I'm talking about terabytes and terabytes of data, and then you run SQL queries against it, and that query is actually split to thousands of machines, and it runs in parallel, and then you get your results back in seconds. But you don't have to worry about machines, you don't have to worry about clusters, everything is done and managed by Google. So we try to make our services as managed as possible, and it makes it really easy to use. And lastly, machine learning. Machine learning is big, and it's getting bigger and bigger. And Google is known for using machine learning in our services. So what we are trying to do is basically, first, we are trying to give our trained models to you in terms of APIs. For example, we have Vision API, where you can pass in an image, and it tells you everything about that image. And I'm going to show a demo of this during my talk. But we have other APIs like Translation API, Speech API, things like that. So we basically, all the models that we built at Google, we are providing them as APIs to you. And then all you have to do is just make a call to use these APIs. And if you need to build your own machine learning model, then there's also Cloud Machine Learning Engine. That's basically TensorFlow, which is an open source project for machine learning, managed by Google for you. So you can use that as well. All right, I have a couple more slides, and then after that, I'm going to start showing you some code, so just hang in there. In terms of deployment options, so if let's say you have an ASP.NET application and you want to deploy that to Google Cloud, you basically have two branches. The first branch is if you're running ASP.NET on Windows, then what you can do is you can get a Windows server on Compute Engine, and you can also get a SQL server on Compute Engine, and then deploy that app on Compute Engine, and that's how you run it, basically. If you made the switch from ASP.NET to ASP.NET Core running on Linux, then you have two choices. You can either, first you take that ASP.NET Core application and create a container out of that. So you put it in a Docker container, basically. And then you host that Docker container in Google Container Repository, which is a private place for your containers. And then you can either deploy it to App Engine Flex, or you can deploy it to Kubernetes running on Container Engine. And I'm going to talk about in detail later, like what's the difference between the two and when you should do both, when you should do App Engine versus Container Engine. But basically, these are the options that you have when it comes to ASP.NET development. And then once you have your ASP.NET app running, you probably want SQL Server running as well, because that's what most people use in .NET world. So you can get a version of that running on Compute Engine, and we support multiple versions, and I'll show you a demo of this. And then we have a Visual Studio plugin to manage Google Cloud resources that I'll show. We have lots of .NET libraries talking to all these Google Cloud services. They're available on NuGet, and I'm going to show some of this as well. And finally, we have PowerShell commandlets, so you can do PowerShell scripting and talk to Google Cloud that way. So basically, we are trying to cover all the different ways you can talk to Google Cloud and try to provide you the libraries and the tools that you need to talk to us. All right, that's it. That's my pitch. So hopefully you're convinced that you should think about Google Cloud at least. Now what I want to do is I want to look at an existing ASP.NET app, run it locally on my machine, take a look at it, and then move it to Google Cloud and see how the process looks like, right? So the app, so basically we'll do this part. We'll do this part, and then we'll do the other part later in the talk. So the application that I want to run and deploy is called Contoso University. Do people know this application? Yeah, it's basically a simple MVC application that shows how to use MVC, pattern and use SQL Server, you basically have this university that has students, that has courses, that has instructors, and everything is backed by a SQL Server. So let's just run this application locally so I can show you how it works, and then later we'll move it to Google Cloud. So here I am in Visual Studio. One thing that you'll realize is that in web.config, I'm using local DB, so I'm running against my local SQL Server. And this Contoso University, it's a model view controller application. So you have models like course, person, student, instructor. And then for each model, you have controllers. So if we look at, for example, student controller, this is the class that controls what happens to a student. So we have different kinds of methods for creating a student, getting the details of a student, things like that. And then we have views. So we have different views for the courses, for students, stuff like that. So I won't get into details of the code that much, but I just want to show you the app real quickly so you know what I'm talking about. So I'm just running this locally. My computer is a little bit slow. All right, so this is the app, and the interesting part is basically you can see the list of students, and it's pulling up the student list from my local DB, and you have a list of students, it's paged, and then we can look at the details of each student, and we can edit each student and save. And same thing with courses. We have different courses with different details. We have instructors with different details. So you get the idea. It's basically a very simple model view controller kind of app that's backed by SQL Server. Now, let's say we want to move this to Google Cloud. What do we need to do? So to move it to Google Cloud, I'm going to install the Google Cloud extension for Visual Studio because it's going to make my life easier. So first we'll do that. Then after that, I need to host this app somewhere, right? So I'm going to get a Windows Server VM with ASP.NET Framework installed on Compute Engine in Google Cloud. We also need a SQL Server, so I'm going to get a SQL Server on Compute Engine. And then I can directly, using the Google Cloud extension, publish my application from Visual Studio to Google Cloud. So that's kind of like the high-level steps that I'm going to do. So let's just do that. Let me close this first. So first, what I'm going to do is, if we go to Tools and Extensions and Updates, I'm going to get the Google Cloud extension for Visual Studio. So I will click on Online. And then here, I'll type Google Cloud. Then you can see that there's a Google Cloud Tools for Visual Studio. I already have it installed, but if it's not installed, you double-click and it will install right here. So once it's installed, if you look at under Tools, there is this new thing called Google Cloud Tools. And let me make this smaller. Oh, sorry. All right, so Google Cloud Tools, and then what I need to do is I need to add my account, my Google Cloud account to Visual Studio. So I hit on Manage Accounts and Add Account. So this opens up a new browser. I have a bunch of accounts, but I'm going to use my development account. So I click, and then I will allow this. So this will give Visual Studio access to talk to Google Cloud. So that's that. And then if I go back to Visual Studio, it's telling me that my account already exists because I already added to Visual Studio, which is OK. Now, what I can do is, again, go to Tools, Google Cloud Tools, and then there's something called Google Cloud Explorer. So this is the guy that will show me my projects and my different things in Google Cloud. So this is my account. And these are all the different projects that I have under my account. I'm looking at the one that's relevant for .NET. And then as you can see, there's Google App Engine. So I have some apps already deployed here. So these are two different versions of my app that's deployed already. I'm going to look at that later. The Compute Engine is the VMs that I have in Google Cloud. So once it loads, we'll see a bunch of VMs. So these are different VMs that I have already. And then there's the cloud storage is like a place where you can store data, basically, any kind of binary data. So I have a bunch of buckets for that. Under the buckets, I have my files. And then there's also something called Google Cloud SQL, which is manage MySQL for you. I don't have a manage MySQL, but if I did, it would show up here. And now, right now, this is limited, but going forward, we want to add everything in here so that anything you can do in Google Cloud Console, you will be able to do it from Visual Studio, ideally. So that's what we are aiming for. Now, the first thing that I want to do is, first I need to get a Windows Server VM with ASP.NET Framework installed in Google Cloud. So to do that, I come to Compute Engine and right-click and say New ASP.NET Instance. This opens up something called Google Cloud Launcher. So Google Cloud Launcher is kind of like a marketplace for different kinds of solutions to deploy on Google Cloud. I need to switch my account because this is my work account. So I will switch to Dev. So on Google Cloud Launcher, there's many things that you can deploy to Google Cloud. It's basically like a solution marketplace. But one of them is called ASP.NET Framework. So this solution will basically install Windows Server and ASP.NET Framework and SQL Express and IIS on a VM. So I just click on Launch on Compute Engine. And then give my deployment a name. So let's just say ASP.NET NDC Sydney. And then you can choose your zone. And I'm happy to report that we are also have an Australia zone now. So I'll just choose Australia Southeast. And you can choose your machine type. So as you can see, there's different kinds of machines like micro, small, 1 CPU all the way to 64 CPUs. And you can also customize it to whatever you want. So I'll just choose 4 CPUs for now. Windows Server support like 2008, 12, 16. I'll choose 16. And then you can get like persistent disk or SSD disk, and you can choose the size. So I'll just keep the default and hit deploy. And this is it. Like this will, within a few minutes, it will give me a Windows Server with ASP.NET Framework installed. While that's happening, let's also get a SQL Server. So to get a SQL Server, I go back here, and then instead of choosing new ASP.NET instance, I'm going to choose new instance. So this will open Google Cloud Console for me again. And I think I need to switch my account again. So I go back to my development account. And then under here, once it loads up, let's call this instance SQL Server NDC. And then again, you can choose your zone. Let's make sure that this is in Australia as well. So this by default is a Linux instance. I want a SQL Server, so I changed the boot disk. And as you can see, we support a bunch of operating systems, a bunch of different like Linux flavors. And there's also SQL Server, Windows SQL Server as well. But what I want is an application, and it's SQL Server. And as you can see, we also have a bunch of different versions of that. So I'll just choose SQL Server 2016 and select. And I'll just keep the defaults, create. And this will give me a SQL Server as well. Obviously, I need to configure this SQL Server and get a static IP for it and things like that. I already have a VM, this one, Contoso Original. This is the VM, Windows VM. And then I also have the SQL Server configured. So we can basically just look at that. So what I can do right now is I can go to my app. And let's say I want to deploy this app now to Google Cloud. What we can do is we can right-click. And then here there's a new menu item called Publish to Google Cloud. So I click on that. And this gives me some options. So it gives me option to deploy to App Engine, Container Engine, or Compute Engine. As you can see, since this is a traditional .NET application, you can only deploy to Compute Engine. So that's why this is the only highlighted one. So I choose that. Oh, and before I do this, I need to change something, by the way. So let me just close this. I need to change web config. And instead of using local DB, let's use the SQL server that I have in the cloud. So the IP of this is the SQL server that I have. So I do that, I save, and now we can publish. So publish to Google Cloud, choose Compute Engine, and now this will pull the VM instances that I can deploy. All right, yep. And then I'll choose Contoso Original, and then this is my account, and then hit publish. And this will basically package my application and deploy to VM running in the cloud, talking to another VM with SQL Server. So within a few seconds, we should see that opening up. can close these guys. All right, so this is the app, and if you go to students, hopefully it will pull the data from the SQL Server. Yeah, you can see that these students are there. So that's what it takes to deploy your app to Google Cloud. Now let's go back to, yeah, it worked, yes.
You clap when you have a working demo.
I know. Well, you're gonna clap more then, because we have more demos coming. All right, so, okay, this is good, but it's not that interesting, to be honest, because now instead of running it on my laptop, it runs in Google Cloud, great. But the power of cloud is basically that now you have all these services available to you. So what I want to do next is, first, the students, they don't have pictures, so I want to add pictures for students. But I need to save this picture somewhere, so I'm going to use Google Cloud Storage to save these pictures. Sending these pictures one by one for each student is going to take a long time. So what I'm going to do is I'm going to use PowerShell commandlets. So once you install Google Cloud SDK, you can have these commandlets, and you can use them to script talking to Google Cloud. So I'm going to use a commandlet to bulk upload these pictures. But you know, students, once you let them upload pictures, some of them will probably upload some pictures that they shouldn't do. So what I want to do is I want to make sure that these pictures are safe, so they're not like violent or adult pictures. To do that, I'm going to use a machine learning API called Vision API. So I'm going to basically pass my image to Vision API, and the Vision API will return some information about the image to me. And from there, I can tell if the image is violent or not. And if it's violent, I won't let the student save the image. So I'm going to use machine learning basically to detect if the image is safe or not. And finally, I want to add some fun facts about students. So, you know, something interesting about the students. But I want them to be able to do this with speech. So I want them to be able to speak, and then we detect their speech and convert it into text, and then send that to as fun fact. But so for that, I'm going to use Speech API, another machine learning API that we have, and see how that works. All right, so let's take a look at this. First, let's look at the images. What I'm going to do is, so I'm in my application now. I created a new service called Image Uploader. So first thing that you will realize with Image Uploader is that it uses this NuGet package, Google Cloud Storage. So this is available on NuGet, so I already installed it. And what it does is Image Uploader takes in a bucket name, because you have to store your image in a bucket in Google Cloud. And then it creates a storage client. So this is like the main interface that you use to talk to Google Cloud Storage. And then I have two methods. One method is upload an image. In here, we get an image, and then we get an ID of the student. And then we use the storage client and just basically pass the image with the ID and get it stored. And then in the end, we get a link to the image that we save in our database. And then there's another method called delete uploaded image. So this, given an ID of the student, it will basically delete that image for that student. So it's very straightforward. And if you look at how these are used, I changed the student controller to basically, when you create a student, it will check if there's an image. And if there's an image, it will use Image Uploader to upload the image. And then it will get a path and set that path as student's image path. And similarly, if we delete a student, we should see it here. If we delete a student, then we also check if there's an image path, and if so, we'll delete it from Google Cloud Storage as well. So let's take a look at this quickly. So I just run this. So this is the same app. All right, it will pull up students, hopefully. Yeah, here are the students. And let me just create a new student, and it will be me. So let's say my last name, Atamel, Mete, and then let's say I enrolled at the beginning of this year. And let's just choose an image. So I think I have some image somewhere. Yeah, here. So I'll choose this image and then create. So this will create the student. It will upload the image to Google Cloud Storage, and then it will save it. And once it's saved, hopefully, in the meantime, you can actually, yeah, it's saved. So let me find myself. If you look at the details, You can see that, yeah, I have a profile picture, which is nice. And if you go back to Google Cloud console, this is a console for my project. If we check the storage section, you will see that I have a bunch of buckets for different things, but this one is for my application. And then you'll see that the image is uploaded there. So it's there already. That's good. But as I mentioned, like doing this one by one for each student is going to take a long time. So when you install Google Cloud SDK, it comes with something called Cloud Shell. So I'll show you that. This is Google Cloud Shell. So this is basically a way for you to talk to Google Cloud from the command line. And there's a command line tool called gcloud. So gcloud is how you would manage your project from command line. So you can do things like gcloud config list, and you'll see which project you're talking to. But then with this SDK, you also get some PowerShell commandlets. So what I did here is that I wrote a PowerShell commandlet. What I have here is it's a bucket and a folder. I define these variables, and then I use this commandlet called new GCS object. So GCS stands for Google Cloud Storage. So I'm basically calling this with the bucket name that I want to save, where I want to save, the folder or my pictures on my machine, and then I'm making sure that these images are publicly available by defining public read. So if you run this PowerShell commandlet, it will basically look at the folder of the images and it will upload them, and I can use them from my application. And there's a bunch of other PowerShell commandlets to do pretty much everything on Google Cloud. I'm just showing you one of them and the stuff that you can do with Google Cloud. So as this is uploading, yeah, as you can see, it's started to upload it. We can go back here, and if we do refresh, you'll see that my pictures folders are there, and I can use them for my application. All right, that's good. But as I mentioned, giving students access to upload any kind of images is not a good idea. So let's make sure that these images are safe to upload. And to do that, we'll use Vision API. So what I did is, if we go back to our application, I created another service called Image Safety Checker. So this Image Safety Checker, the first thing that you realize is, again, using another NuGet package called Google Cloud Vision. So this is the NuGet package for Vision API. And what we do is, just like before, we create a client to talk to Vision API. And once we have the client, I have a single method called isSafe. And this method gets an image, and then it calls the Vision API detect safe search async method. So this basically passes the image to Vision API, and then Vision API will return us some annotations. And these annotations, they have 4 dimensions: adult, violence, spoof, or medical. And then you can check the likelihood of that. So you can check the likelihood of this image being an adult image, being a violent image, stuff like that. So what I'm doing here is basically I'm making sure that this image is not likely to be an adult image or violent image or spoof image or medical image, okay? And if all of that is true, then I will return true from this isSafe method. Now, if you look at how I use this isSafe method, I created another image uploader. This time it's called Safe Image Uploader. That's extending from image uploader, the original image uploader. And then what we are doing is basically we are overriding the upload image method. And once we get an image and an ID, we call this image safety checker and see if the image is safe. If it's not safe, we throw an exception. If it's safe, we call the base method, which is basically upload the image. So that's how I check that image is safe. So let's see if this works. I go back to my app. Yeah, that's me. Actually, let me edit myself. And let's choose a picture that's this one. I don't know if you can see it, but it's basically a guy shooting. So it's a violent image, and we don't like that. But let's see if the Vision API is going to prevent that to be from being uploaded. Yeah, as you can see, it says unable to save changes because we sent the image to Vision API. Vision API told us it's violent image, and then from there we threw an exception. So it was pretty easy, basically, to use machine learning with Vision API. And the last thing that I want to do is the speech API. So I have this section called fun facts, something fun about the person, but I want the students to be able to talk to it and change the, so basically convert the speech into text. So to do that, we'll use Speech API. So if I go back to my application, I created another couple of services. One is called Voice Recorder. This is not an interesting class. It basically, given some seconds, it records your voice and saves it to a file. So it's nothing fancy. But the voice recognizer is the class that's more interesting. In here, we are again using a NuGet package for Speech API. And then what we do is we create a speech client again. So as you can see, we always use the NuGet package, and then we create a client to talk to that service. So in this case, it's a speech client. And then we have a method called recognize that basically calls this sync recognize async method on the speech client. So we are basically just passing the file that has our speech and then getting a response. And the response has a number of results and a number of alternatives. So when you use Speech API, usually you get one result, but sometimes you get multiple results depending on what you said. And some of those results that they have, well, actually all of them, they have some kind of confidence. And you can choose the one with the highest confidence. But what I'm doing here is I'm just looking at the results and looking at the alternatives and just choose the first one and get the transcript from that. So I'm just picking up the first result, basically. So this is it. This is how you can use Speech API. And if we look at how this guy is used, in Student Controller, I have a new thing called record. So this is what happens when you press the record button. We call voice recorder, and then we record for 3 seconds from the microphone to a file. Then we call voice recognizer with that file path, and then we call recognize method on the recognizer, get a transcript, and then we set that as fun fact for the student. So that's what we do. So let's try this out. It might not work because every time I do this with the microphone and stuff, it doesn't work, but let's give it a try. Maybe it will work. So for fun fact, we'll say, he is in Sydney. Oh, yeah, it didn't work. One more time. He is in Sydney. Nope. Yeah, I won't try because with the echo and everything, it doesn't usually work. But if you do it with proper microphone and everything, it usually works. All right. All right, so that's it basically. That's what I want to show you with the traditional ASP.NET applications and the kind of services that you have. I mean, we have much more services. I couldn't show them all, but I just want to give you an idea of what kind of stuff you can do. Now let's talk about the new containerized world, because that's what the world is getting into nowadays. In terms of why containers, if you look at how we used to deploy software, this is how it kind of looked like. We had a physical machine, then we would install the operating system kernel there, then we'll install a bunch of libraries on top of the operating system, and then we will install all the applications on top of the libraries, right? The good thing about this was that it was easy, one machine, one operating system, one set of libraries, but the bad thing is that there was no isolation whatsoever between your applications. So if you change anything about the operating system, or if you change anything about the libraries, you could potentially break multiple applications. Now, after that, we had virtual machines. So the idea of virtual machines is that in a single physical machine, you have multiple operating systems virtualized. So this way, the operating system, libraries, and app is virtualized in a single virtual machine. So there's total isolation between applications, which is good. But the bad thing in this case is that instead of dealing with one operating system, you have to deal with 4 operating systems. And these virtual machines, they're not lightweight. They're kind of quite heavy. So you need to maintain them. So it wasn't so easy. So the containers, they kind of combine the best of both worlds. So in containers, you have a single physical machine and single operating system, but you're virtualizing from libraries up. So your app and its dependencies, you put in something called container image, and that way, your apps are completely isolated from each other because they have their code and their libraries isolated, but they run on a single operating system, so you don't have to worry about multiple operating systems anymore. So that's the thing. That's the good thing about containers. they are lightweight compared to virtual machines. Instead of having gigabytes of virtual machine file, you have megabytes, like 10 or 20 megabytes with containers. I mean, sometimes they can be a little bit bigger than that, but usually they are much more lightweight than virtual machines. And they are sealed and isolated, so you can have multiple containers running on an operating system, and they don't interfere with each other. They are very easy to deploy, very easy to introspect, so you can actually get into container and look at what's happening. And for me, the most important part is they're composable. So you can actually have a base image that you depend on, your application depends on, and you can layer your app on top as an image. And if someone needs to depend on your application, they can create another image on top of your own application. So you can layer your dependencies as images. This way, you can basically compose your dependencies with containers. And Docker is the mostly used container platform, I guess. But there are others, like Rocket from CoreOS as well, that's coming up. And I'm sure there will be more in the future. So in terms of how you can deploy containers on Google Cloud, what you do is you take an ASP.NET Core application, you containerize it with Docker, and then after that you have a choice. You can either deploy it to App Engine or you can deploy it to Kubernetes. Now, the difference is App Engine is the easiest way to deploy containers, ASP.NET containers on Google Cloud, because with App Engine, you basically pass your container and tell App Engine, just run this container, and I don't care how you scale it, how you run it, where you run it, I don't care. And App Engine will basically run your container on a single machine, but then if you get more load, it will automatically scale to multiple machines. So it basically just runs your container at scale, and you get like some nice features about App Engine as well, like traffic splitting, versioning, and things like that I'm going to show. So that's easy to do, but sometimes you want to actually build a container cluster, and you want to be able to pick and choose what you have in your cluster, and you want to scale individual pieces independently. So for those, there's something called Kubernetes. It's an open source project to manage containers, and we basically host Kubernetes for you. So you can use that on Container Engine and create your own container cluster. So if you want an easy solution, use App Engine. If you want a more custom solution, then use Kubernetes on Container Engine. That's the answer. So let's talk about App Engine Flex. So App Engine Flex is, as I mentioned, you just deploy your container, and App Engine just figures out how to run it and scale it. By default, you get dashboards for your application, so you can see the latency, the CPUs used, stuff like that. You get versioning, so every time you deploy your application, you get a new version, and with different versions, you can do like things like traffic splitting. So you can split the traffic between different versions, do A/B testing, do like canary deployments, things like that. Yeah, so as I mentioned, you can do traffic splitting. And auto-scaling. Auto-scaling is really important by default. By just deploying to App Engine, you get auto-scale. So things scale up and down without you having to do anything. So let me show you a quick example of App Engine Flex with ASP.NET Core. So once you install Google Cloud extension for Visual Studio, you actually get some templates. So if you go to File, New Project, you will see that there's like a Google Cloud Platform section. And with this, you can get templates for ASP.NET, and you can also get templates for ASP.NET Core on App Engine. So I already created an app, this one, the ASP.NET Core Web API. It's right here. And then by default, you get a app settings.json file. So this is the JSON file that kind of defines your application to App Engine. So I specify my project, and then I specify my project, my service name, and this is my version, the default version of my application. So if you want to deploy this to App Engine, what you can do is you can right-click and then publish to Google Cloud. Now you'll realize that at this point, we have two choices again, like App Engine Flex or Container Engine. So if you have a Kubernetes cluster running, you can actually deploy it there from here. But I want to deploy to App Engine Flex. And then as you can see, the Compute Engine is not highlighted because this is an ASP.NET Core application, so it doesn't make sense to deploy into a VM. You can deploy it here. So I choose Flex, and you can give your version name some name. So let's just call this version 3. And when you deploy a version, you can promote it, meaning your version gets all the traffic right away. But I don't want to promote this. I want to deploy this version and then test it out. And if everything is good, I want to promote it myself afterwards. So I uncheck that and then open site after publishing, meaning once it's deployed, can I open it from my laptop? I don't want to open it. So I'll just hit publish. So what will happen right now is the code will be bundled and it will be sent to Google Cloud. And Google Cloud will, in the cloud, will create a container for this application. And it will host that container in Google Cloud repository for containers. And then from there, once the image is there, the container image, it will be deployed to Google App Engine Flex. The reason why we build a container and save it is that once the container image is in Google Cloud, you can actually deploy it to anywhere you want. You can deploy it to a container engine or anywhere you want. So that's why we create the container for you. So this will happen, but as it happens, I'll show you the App Engine instance that I deployed earlier. So if we go here, and if I go here, you can see that I have some versions. So I have 2 versions already deployed, version 3 and this other version. And then by default, you get a dashboard with latency, traffic, VM, CPU, instances, all that kind of stuff. I don't have anything in here because I just deployed these apps and no one is using them. But if someone is using it, yeah, you would see some dashboards here. If I click on a version section, I can see the different versions I have. So this version is being served by 2 instances. So actually behind this version, there's 2 VMs. But this is something that you don't have to worry about. Google Cloud figures out how many VMs to use and how to auto-scale that. And this is getting 100% of the traffic. This is not getting any traffic. So once we have the new version, we'll see a new version in our list. And what you can do actually is you can split the traffic. So let's say I want to split the traffic in these 2 versions, like 50%, 50%. I can click here. And let's do cookie-based splitting. And then I'll say version 3 will get 50. Oop. I think there's something wrong. Oh, yeah. The problem is I stopped this version, so it's not using any VMs. And because of that, I cannot give traffic to it. That's what it's telling me. But if it wasn't stopped, I could basically drag any kind of traffic I want here. So that's it. Anything else I want to show here? I think that's all I wanted to show. And then this guy will basically, within a few minutes, it should, this one, it should deploy to App Engine if everything goes well. There's an error. We'll ignore that. All right. And the last thing I want to talk about is Kubernetes. So Kubernetes is an open source project to manage containers, because containers are nice. They give you a consistent environment to run your applications, but you still need to manage them in production. So usually you need some kind of container management platform, and Kubernetes is one of the most popular ones. It's supported by Google. I mean, it came from Google, but now it's supported by Google. It can run on Amazon. It can run on Azure. The great thing about Kubernetes is that it can run pretty much anywhere. It can run on your laptop. It can run on Google Cloud, anywhere. It basically came from something called Borg. So at Google, we've been running containers for a long time, for like 12 years. And we have an internal system called Borg. So people who actually worked on Borg, they learned from it over these years, and they created Kubernetes for the open source world. So even though it's open source and it's kind of like a new project, it's very mature because it came from the learnings of Borg. And it's 100% open source. And I think it's one of the most popular projects on GitHub. It's like the most top, like 0.5% popular projects. It's written in Go. And the whole idea of Kubernetes is that you want to basically manage applications and not machines. So you create a Kubernetes cluster, and you just deploy what's called your pods. And Kubernetes basically figures out where to deploy that, and you don't have to worry about like virtual machines yourself. I actually have a talk on this, like an hour-long talk, because it's very involved. I just want to mention it here so that you know that it exists. And on Google Cloud, we have something called Container Engine that basically hosts Kubernetes for you so that you can use it in a much easier way. At the very high level, this is how it looks like, a Kubernetes cluster. So there's a master, And then there are nodes where you schedule containers. And the master and the nodes, they talk through something called kubelets. And the master has things like controllers that controls what goes on nodes. There's like scheduler. There's an etcd for the cluster state. And as a user, you basically talk to the master either through the API, CLI, or user interface. And at Google Cloud, what you usually do with Kubernetes is something like this. So you create your application, and you create a Docker file for your application. And that's basically like the Docker image recipe. And then once you have that recipe, you push that image to Google Container Registry. So your image lives in Google Container Registry. Then you use gcloud to get a Kubernetes cluster. So with one command, you say, give me a Kubernetes cluster with this many nodes to schedule for my images. Once you have your Kubernetes cluster, you use another command line tool called kubectl. So kubectl is basically what you use to manage Kubernetes. So you will basically say, please schedule this image on my cluster, but you don't specify any machines or anything like that. You just say, schedule this pod, and then it will be scheduled on some of the empty nodes in Google Cloud. All right, so that's how it looks like. And that's all I want to say, basically. So as a summary, we started with ASP.NET running locally. We moved that to Windows Server and SQL Server in Google Cloud. We added pictures with cloud storage. We added intelligence with machine learning APIs. And then we tried the new ASP.NET Core on App Engine Flex. And I could have shown you much more on Kubernetes, but I just basically mentioned it here because of the time constraints. And hopefully this was useful. If you want the links, basically these are the links for our .NET support on Google Cloud and Windows support. This is the App Engine page. This is the Container Engine page. This is Kubernetes. And if you want the slides, just follow me, and I'll put the slides up there. And if you have any questions, I guess we have some time for questions right now. I can take some questions. But I'm also going to be at the Google Cloud booth, so you can stop by there, and I'll be happy to answer your questions. So thanks very much. So any questions? Yep.
So from what I understand, Compute Engine is the infrastructure as a service offering, and the App Engine is more of the container platform as a service, but not really platform as a service, container one. It's kind of IaaS and...
Yes. Yeah, that's true. Yep. And Cloud Functions is kind of like the serverless offering, but that only supports Node.js as of today. In the future, it will support other languages. Yep.
Normally, you won't change your code if you have a new version of your new bit, isn't it? I mean, you don't see like something .v1 in the name of the...
I think most of the NuGet packages, they were like betas, and that's why they had like version 1, version 2 until they GA. But the ones that are G8, I don't think they have versions anymore.
And do they come in .NET Standard or they're for full .NET, those packages?
Oh, yeah, they're supported both on .NET Standard and .NET Core. Not all of them, but they will eventually, all of them will work on both. Yep. Yep.
So for Google Cloud, is it only available in subscription pricing? Is there like a free deployment we could play with?
Yes, there's actually a free tier. So I think if we go to cloud.google.com/, I think it's called free. Hopefully, it's either free or free tier. Yeah. So if you go here, it will tell you exactly what you can do for free. So you get like $300 credit for 12 months. And then there's certain things that are always free if you don't use them that much. And this will tell you all the information.
Okay.
Yep. Yes?
Just regarding the like pricing difference between the IaaS services you have in Google Cloud versus Azure, do we have like a rough, I guess, comparison? Like, is it how much cheaper or percentage-wise?
It's really hard to answer because it really depends on the service and then how that service is charged and how do you use it. So I don't have an exact answer on that, but overall, we try to be cheaper. At the base level, also we try to be cheaper with the features that we provide. So overall it's cheaper, but in terms of like what percentage, how it is, I mean, some people told me, oh, we saved 3 times because we use Google Cloud. Some people said 20%. So it really depends on the service and how they use it. I don't have like a concrete answer. Yep.
Hi. Any plans to add SQL Server to your Cloud SQL offering?
So you mean managed SQL Server?
Yeah.
I think that we heard that a lot, but I don't know the exact time frame. But it's something that we are aware that people want.
What's the story for like secrets management? Is there a service for that at the moment, or is that things you have to manage yourself?
Secrets management. I mean, in Kubernetes, there's something called secrets, where you basically define it in a single place, and then it gets attached to your containers as a volume. But in terms of Google Cloud in general, I don't know if we have anything for secret management. I mean, we have like identity and access management, where you can define who can access where. Maybe as part of that there's something, but I'm not sure. Any other questions? No? One more? Okay.
With the app engine, can you set up sort of VPCs?
VPCs? Oh yeah. I mean, I didn't talk about networking at all, but there's all sorts of things that you can do with networking, and yeah, I don't really look into that much because I'm more like an application developer. But I know that we have lots of networking things that you can do and set up your own private networks and set up your VPNs between your data centers and Google Cloud, things like that. All right. Any other questions? One more. Yep.
Just a little bit, maybe out of the topic. I'm not sure. Just running Kubernetes on Windows, like is that just for, I guess, for as developers, is that pretty stable at this stage?
So Kubernetes master has to run on Linux. That cannot run on Windows. But there's and also the Kubernetes nodes, so the actual nodes where you schedule containers, that's also have been Linux. But there's work now to have Windows nodes as well. So I think there's a company called Abrenda that's working on that, and there's a working group within Kubernetes that's working on that. From what I heard last time is that Windows nodes are in alpha or beta stage, but it's not production ready yet. But it should be, I'm guessing sometime this year is my guess, that will be production ready. And once it is, then you can have a Kubernetes cluster that can have Linux containers and Windows containers in a single cluster, which should be good. And then that way you can also run ASP.NET traditional on Kubernetes. Any last questions? All right. Thanks very much, and enjoy the rest of the conference.